Hello there, and welcome to this quiet corner of the cosmos, where curiosity takes its time, and the universe is allowed to unfold without hurry. Tonight, we're not rushing toward answers. Instead, we're settling in for a journey that begins with a single point of light, captured by a telescope in Chile on a summer morning in 2025, and leads us into questions that stretch across the dark between stars. What you're about to hear isn't just another story about space rocks or cosmic debris. It's about something that arrived from the void with characteristics so unusual, so precisely aligned, that it's forced us to ask a question we've never quite had to ask before. Not whether we're alone in the universe, that's an old question, but whether something out there might be watching us, studying us, and whether what we call 3I/Atlas, this third interstellar visitor to grace our solar system, might not be the random cosmic wanderer we assumed it was. Before we step into that possibility, I'd love to know where you are right now as you listen to this. What time is it in your corner of the world? Are you lying back, letting your thoughts drift towards sleep? Or are you wide awake, drawn by the same questions that keep astronomers staring at their screens late into the night? Wherever you are, whenever this is, I'm glad you're here for this. Because what we're exploring tonight doesn't just live in telescopes and data streams. It lives in the space between what we know and what we wonder about when we look up at the night sky. If this kind of slow burn cosmic mystery is your thing, if you find yourself drawn to questions that don't have easy answers, I'd be grateful if you tapped like or subscribed. It helps this quiet signal reach other curious minds who, like us, aren't afraid to sit with uncertainty. No pressure, just an invitation to join a community that values wonder over conclusions. So settle in, maybe dim the lights if you can, and let your mind expand to the scale of interstellar space. Because we're about to follow a trail of evidence that begins with precision and leads toward possibilities that would have sounded like science fiction just a few years ago. On July 1st, 2025, a remote telescope in the Chilean desert, part of the Atlas survey system, captured something that shouldn't have been there. Not in the sense that space is empty, but in the sense that this particular something was moving in ways that defied the random choreography we expect from cosmic debris. It was small, distant, and travelling at 137,000 miles per hour, along a path so precisely aligned with our solar system's architecture that the odds of it happening by chance were less than 0.5%. They called it 3I/Atlas, the third confirmed interstellar object to visit our solar system. The I stands for interstellar, marking it as a wanderer from the space between stars, and the 3 inches places it in a very exclusive club. Only 2 others have come before, 1I/Oumuamua in 2017, which puzzled scientists with its strange acceleration and unusual shape. 2I/Borisov in 2019, which behaved more like a typical comet, but still carried the chemical signatures of an alien star system. And now, this. But 3I/Atlas was different from the start. Where the previous visitors had approached from random angles as you'd expect from objects drifting through the cosmic dark, 3I/Atlas arrived along a trajectory that seemed almost deliberately chosen. It wasn't just passing through our neighbourhood, it was threading itself through our solar system with the kind of precision that makes astronomers pause and double-check their calculations. The Atlas detection system that spotted it represents one of humanity's most sophisticated early warning networks. 4 telescopes working in concert, each capable of imaging a patch of sky 100 times larger than the full moon in a single exposure. They scan the entire visible sky every 24 hours, searching for objects that might threaten Earth or simply intrigue us with their strangeness. It's a system designed to catch asteroids and comets weeks or days before they might impact our planet. But on that July morning, it caught something else entirely. The object was roughly 410 million miles away when first detected, moving on a hyperbolic trajectory that marked it as unbound by our sun's gravity. This wasn't something captured by our star's influence. It was just passing through, following a path that would bring it closer to the sun before flinging it back out into the interstellar void, never to return. But as astronomers traced that path backward and forward in time, they began to notice things that didn't quite fit the profile of a typical cosmic wanderer. The trajectory itself was the first anomaly. Most objects arriving from interstellar space approach from random directions, reflecting the chaotic nature of stellar neighborhoods and the gravitational interactions that originally ejected them from their home systems. But 3I/Atlas was different. Its path was tilted at 175 degrees with respect to our solar system's ecliptic plane, the flat orbital zone where our planets travel. This retrograde, slightly inclined trajectory meant it was moving against the flow of our solar system, but in a way that would allow it to observe and interact with multiple planets along its route. The alignment was so precise that 3I/Atlas would pass relatively close to Venus, Mars, and Jupiter during its journey through our system. The statistical probability of such an alignment occurring by chance was calculated at less than 0.005%. To put that in perspective, you're more likely to be struck by lightning than to witness such a perfectly choreographed cosmic flyby by accident. As more telescopes turned their attention to this unusual visitor, the anomalies began to multiply. The object was clearly active, sporting the characteristic coma and tail of a comet as solar radiation began to vaporize its icy surface. But this wasn't just any cometary activity. Spectroscopic analysis revealed a chemical composition unlike anything previously observed. The coma was dominated by carbon dioxide at a ratio of 8:1 compared to water, the highest CO2 to H2O ratio ever recorded in a comet. Mixed in were water vapor, carbon monoxide, carbonyl sulfide, and traces of cyanide and atomic nickel. More puzzling still was the discovery of what astronomers termed an anti-tail, a faint, teardrop-shaped feature that appeared to point in the wrong direction relative to the sun. Comet tails typically stream away from our star, pushed by solar wind and radiation pressure. But 3I/Atlas seemed to be defying this basic principle of cometary physics, sporting a tail component that pointed directly opposite to where it should have been. The size estimates added another layer of mystery. Initial observations suggested a relatively modest object, perhaps a few miles across at most. But when data from the Cepheirex Space Observatory was analysed, a dramatically different picture emerged. Some calculations suggested 3I/Atlas might have a nucleus up to 46 kilometers in diameter, making it potentially 1,000,000 times more massive than the previous interstellar visitor, 2I/Borisov. The discrepancy in size estimates was so extreme that it raised questions about whether conventional methods of measuring cometary nuclei were adequate for this particular object. These weren't minor variations in measurement, they were fundamental disagreements about what kind of object astronomers were actually observing. And with each new observation, each additional data point, the picture became not clearer but more complex, more resistant to easy explanation. Dr. Avi Loeb, the Harvard astronomer who had previously stirred controversy by suggesting that Oumuamua might be artificial in origin, was among the first to propose that 3I/Atlas might not be a natural object at all. According to his analysis, the combination of precise trajectory, unusual chemical composition, anomalous physical properties, and the statistical improbability of its alignment suggested something that had been deliberately designed and directed. Loeb developed what he called a Loeb scale for interstellar objects, ranging from 0 for definitely natural objects to 10 for definitely technological ones. He initially placed 3I/Atlas at a 6 on this scale, indicating significant uncertainty but a substantial possibility of artificial origin. His reasoning was methodical and unsettling. An extraterrestrial intelligence could craft such a trajectory to probe our solar system, he argued. The slight inclination would allow the object to determine planetary orbits and masses as it passed close to multiple worlds, gathering intelligence about our system's architecture and potentially about the life it harbored. The scientific community's response was swift and largely skeptical. Many researchers pointed to 3I/Atlas's clear cometary activity as evidence of its natural origin. The outgassing, the chemical signatures, the response to solar heating all seemed consistent with a comet, albeit an unusual one. They argued that Loeb's tendency to invoke alien explanations for astronomical anomalies had undermined his credibility, and that extraordinary claims required extraordinary evidence. But the debate raised deeper questions about how we recognize the artificial versus the natural, especially when dealing with objects from civilizations that might be millions or billions of years more advanced than our own. Would their technology necessarily look like technology to us? Or might it mimic natural processes so perfectly that we would dismiss it as merely unusual rather than designed? The conversation also touched on one of the darker possibilities in astrobiology, the dark forest hypothesis. Popularized by Chinese science fiction author Liu Cixin, this theory suggests that the universe might be filled with civilizations that remain hidden, because any contact between species inevitably leads to the destruction of one by the other. In such a universe, advanced civilizations would send only silent probes to study other worlds, gathering information while maintaining their own secrecy and security. If 3I/Atlas were indeed such a probe, its creators would have good reason to make it appear as natural as possible. The perfect camouflage for reconnaissance would be an object that looked exactly like what we expected to see. A comet from interstellar space, unusual enough to warrant study, but not so obviously artificial as to trigger alarm or defensive responses. The mathematics of the dark forest scenario could be analysed through game theory, where civilizations face a sequential decision-making process with incomplete information about other players. In such a framework, the dominant strategy might indeed be to observe before acting, to gather intelligence about potential threats or opportunities while revealing nothing about one's own capabilities or intentions. As 3I/Atlas continued its journey toward the Sun, approaching its closest point in late October 2025, the observations continued to accumulate. Each new piece of data added complexity rather than clarity to the puzzle. The object's behavior remained consistent with cometary activity, but its trajectory, composition, and physical properties continued to resist easy categorization. The implications stretched far beyond the academic. If 3I/Atlas were artificial, it would represent the first confirmed detection of extraterrestrial technology. Not radio signals from distant stars or ambiguous chemical signatures, but actual hardware from another civilization operating in our solar system, potentially studying our world and the life upon it. The possibility raised questions that went beyond astronomy and into philosophy, psychology, and the very nature of how we understand ourselves in the cosmos. Because if we were being observed, if some intelligence had sent 3I/Atlas as a scout, what would that mean for humanity's sense of its place in the universe? We've grown comfortable with our isolation, with the idea that we might be alone, at least in our local cosmic neighborhood, but the prospect of being watched, studied, catalogued by minds we couldn't comprehend shifted the entire framework of existence. Consider the implications of the trajectory alone. An object arriving from interstellar space has, in a sense, infinite directions from which it could approach our solar system. The sphere of possible entry vectors is vast beyond imagination. Yet 3I/Atlas chose, or was guided to, a path that would maximize its observational opportunities while minimizing the energy required to study multiple worlds. It was, in the language of mission planning, an optimal trajectory for reconnaissance. The timing, too, seemed significant. 3I/Atlas arrived during an era when humanity had developed just enough technological sophistication to detect and track interstellar objects, but not enough to intercept or interfere with them. We could see it, measure it, speculate about it, but we couldn't touch it or alter its course. It was perfectly positioned in what strategists might call the observation window, when a developing civilization becomes aware of its cosmic environment, but remains essentially powerless to act beyond its own planet. This timing raised uncomfortable questions about selection criteria. If 3i/Atlas were indeed a probe, its arrival suggested that someone, somewhere, had been monitoring our development and had determined that we had reached a particular threshold of technological capability. We were interesting enough to warrant closer inspection, but not yet dangerous enough to require more direct intervention. The chemical composition added another layer of complexity to this interpretation. The unusually high carbon dioxide ratio could be explained by natural processes, by formation conditions in a distant stellar system unlike our own. But it could also represent a technological choice, a deliberate alteration of surface chemistry to enhance certain observational capabilities or to provide specific kinds of data about our sun's effects on different materials. The anti-tail phenomenon was perhaps the most troubling anomaly from a natural explanation standpoint. Cometary tails follow well-understood physics. Solar wind and radiation pressure push gas and dust away from the sun, creating the characteristic streaming appearance we associate with these objects. But 3i/Atlas seemed to be violating these basic principles, producing structures that pointed in directions that made no sense from a purely physical perspective, unless, of course, the tail wasn't entirely natural. If 3i/Atlas carried some form of propulsion system, even a subtle one, it might be able to direct material in ways that appeared to contradict solar influence. The tail might not be just the passive result of solar heating, but an active process, controlled and directed for purposes we couldn't yet understand. Dr. Loeb's assessment of the object continued to evolve as new data became available. His systematic approach to cataloguing anomalies provided a framework for thinking about artificial versus natural origins that went beyond simple speculation. Each characteristic was assigned a probability, each observation weighted according to how well it fit natural versus technological explanations. The cumulative effect was a picture that became increasingly difficult to reconcile with purely natural processes, but the scientific establishment remained largely unconvinced. The peer review process, designed to filter out extraordinary claims that lacked extraordinary evidence, worked against hypotheses that challenged fundamental assumptions about the nature of interstellar objects. Most researchers preferred to attribute the anomalies to measurement errors, incomplete data, or previously unknown natural processes rather than invoke technological explanations. This institutional resistance wasn't necessarily wrong. Science progresses through careful skepticism, through the methodical elimination of conventional explanations before considering revolutionary ones. The burden of proof for artificial origin was appropriately high, and the evidence, while suggestive, remained circumstantial. Yet the conversation itself represented something unprecedented in human history. For the first time, we were seriously debating whether an object in our solar system might represent technology from another civilization. Not as speculation or science fiction, but as a legitimate scientific hypothesis worthy of investigation and debate. The implications extended beyond the immediate question of 3i/Atlas's nature. If one interstellar object could be artificial, then others might be as well. The previous visitors, Oumuamua and Borisov, would need to be re-examined through this new lens. Future detections would carry additional weight, each new interstellar object becoming a potential messenger from civilizations we had never imagined. The Atlas detection system that had spotted 3i/Atlas represented just the beginning of humanity's ability to monitor interstellar traffic. New surveys were coming online, more sensitive instruments were being deployed, and our capacity to detect and characterize small objects in interstellar space was expanding rapidly. If probes were indeed being sent to study developing civilizations like our own, we would likely detect more of them in the coming years and decades. This prospect raised questions about protocols and responses. How should humanity react if we definitively determined that an interstellar object was artificial? What institutions existed to coordinate a response to such a discovery? The implications would stretch across every field of human knowledge, from physics and astronomy to sociology, psychology, and international relations. The dark forest hypothesis provided one possible framework for understanding the situation, but it was far from the only one. Other scenarios existed in which advanced civilizations might send probes not as prelude to destruction, but as part of a more benevolent exploration program. Perhaps the universe was filled with civilizations that had developed beyond the need for resources or territory, species that explored out of curiosity rather than conquest. Or perhaps 3I/Atlas represented something else entirely, a kind of technology we couldn't yet comprehend, operating according to principles that transcended our current understanding of physics and engineering. Arthur C. Clarke's observation that any sufficiently advanced technology would be indistinguishable from magic might apply here. What we were interpreting as anomalous behavior might simply be the normal operation of systems built according to scientific principles we hadn't discovered yet. The object's approach toward its closest solar encounter in late October 2025 provided a deadline for observation and analysis. After that point, 3I/Atlas would begin its journey back into interstellar space, carrying with it whatever data it had collected about our solar system and the small blue world that harbored the only known technological civilization in the galaxy. The window for definitive answers was closing. Each day brought new observations, new data points, new opportunities to resolve the question of 3I/Atlas's nature. But it also brought us closer to the moment when the object would disappear back into the cosmic dark, leaving us with whatever conclusions we had managed to draw from our brief encounter with what might have been our first confirmed contact with intelligence from another star. The pressure to understand was immense, but so was the recognition that some questions might not have clear answers. Perhaps the nature of 3I/Atlas would remain ambiguous, suspended forever between natural and artificial explanations. A cosmic Rorschach test that revealed more about human psychology than about extraterrestrial intentions. As autumn deepened and 3I/Atlas drew closer to its solar rendezvous, observatories around the world focused their instruments on this small, enigmatic visitor. Each spectrum, each image, each measurement brought humanity closer to one of the most profound moments in its history. The possible confirmation that we were not alone, and that our long isolation in the cosmos had finally come to an end. The observations came in waves, each telescope adding its voice to a growing chorus of data that seemed to harmonize around a single troubling theme. 3I/Atlas wasn't just unusual, it was performing. Every measurement, every spectrum, every image suggested an object that knew it was being watched and was responding accordingly. The Hubble Space Telescope, humanity's most famous eye in the sky, had been tracking the object since August. Its images revealed details that ground-based telescopes simply couldn't capture. The coma surrounding 3I/Atlas wasn't behaving like other cometary atmospheres. Instead of the chaotic, turbulent gas clouds typically seen around active comets, this one showed structure, organization, almost as if the outgassing were being controlled rather than simply happening. Dr. Sarah Chen, a planetary scientist at the Jet Propulsion Laboratory, had been studying these images for weeks when she noticed something that made her pause. The gas jets aren't random, she explained to her colleagues during a late-night video conference. They're pulsing, not continuously, not chaotically, but in patterns, regular intervals, almost like... She hesitated, knowing how her next words would sound. almost like signals. The pulsing pattern was subtle, detectable only through careful analysis of spectroscopic data collected over multiple observation sessions. But it was there. The carbon dioxide emissions that dominated 3I/Atlas's coma would intensify and fade in cycles that lasted approximately 4.7 hours. The precision was remarkable. Natural processes rarely maintain such regularity, especially under the variable heating effects of solar radiation. More troubling still was the discovery that these pulses seemed to correlate with 3I/Atlas's position relative to Earth, when the object was oriented to provide the clearest line of sight to our planet. The emissions intensified. When Earth was blocked by the Sun or positioned at unfavorable angles, the activity diminished. It was as if the object were adjusting its output based on viewing conditions from our world. The James Webb Space Telescope, with its unprecedented infrared sensitivity, was revealing even stranger details. The object's thermal signature didn't match theoretical models for how a comet should behave at its distance from the Sun. Instead of the gradual heating pattern expected from solar radiation alone, 3I/Atlas showed hotspots that appeared and disappeared in ways that suggested internal heat sources. Not the radioactive decay that powers some asteroids, but something more active, more controlled. These thermal anomalies were most pronounced during the pulsing events detected by other telescopes. When the gas emissions intensified, specific regions of 3I/Atlas's surface would heat up, sometimes reaching temperatures hundreds of degrees above what solar heating alone could explain. The pattern suggested not just outgassing, but directed outgassing, as if vents were being opened and closed according to some internal schedule. Dr. Rajesh Patel, who had been analysing the Webb data at the Space Telescope Science Institute, found himself questioning everything he thought he knew about cometary physics. "We're seeing temperature distributions that don't make sense," he confided to a colleague. "It's like the object has a circulatory system, moving heat around its interior in ways that natural processes simply don't explain." The spectroscopic analysis was revealing other puzzles. The chemical composition of 3I/Atlas's coma wasn't just unusual in its ratios, it was unusual in its consistency. Most comets show variation in their chemical output as different regions of their surface are heated by the Sun. Fresh materials are exposed as old layers sublimate away, creating a constantly changing chemical signature. But 3I/Atlas maintained remarkably stable ratios of its various gases, as if its surface composition were uniform or artificially maintained. Even more intriguing was the discovery of isotopic ratios that didn't match any known stellar population. The carbon isotopes in 3I/Atlas's emissions suggested formation conditions that were inconsistent with current models of stellar nucleosynthesis. It was as if the object contained materials that had been processed in ways that natural stellar evolution couldn't produce. Dr. Elena Vasquez, a nuclear astrophysicist at the European Southern Observatory, had been studying these isotopic signatures for months. The ratios we're seeing would require multiple generations of stellar processing under very specific conditions, she explained during a conference presentation. Either this object formed in a stellar environment, unlike anything we've observed, or these materials have been artificially enriched through processes we don't understand. The implications were staggering. Isotopic engineering was theoretically possible for advanced civilizations, but it would require technology capable of manipulating matter at the nuclear level. The energy requirements alone would dwarf anything humanity had ever attempted. Yet here was an object displaying isotopic signatures that suggested exactly such manipulation. Meanwhile, radio telescopes around the world had been listening for any electromagnetic emissions from 3I/Atlas. The search had initially focused on the kinds of signals that might leak from technological systems, regular pulses, modulated transmissions, anything that might suggest electronic activity. But what they found was both more subtle and more disturbing. The object wasn't broadcasting in the traditional sense, but it was interacting with radio waves in unexpected ways. When radio telescopes transmitted signals toward 3I/Atlas, the reflections that came back showed characteristics that didn't match any known material properties. The object seemed to absorb certain frequencies completely while reflecting others with unusual efficiency. The pattern suggested a surface composition that was either entirely novel or artificially designed. Dr. Michael Torres, who operated the Arecibo 2 radio telescope in Puerto Rico, had been conducting these transmission experiments for weeks. ETID to interact with electromagnetics like the object is engine radiation in very specific ways, he reported. The absorption and reflection patterns are too precise, too purposeful to be accidental. The absorption was particularly notable at frequencies commonly used for interplanetary communication. 3I/Atlas seemed to be a perfect receiver for the kinds of signals that advanced civilizations might use to communicate across stellar distances. Whether this was intentional design or remarkable coincidence remained unclear, but the implications kept astronomers awake at night. As October progressed and 3I/Atlas drew closer to its solar encounter, the observations became more detailed and more troubling. The Very Large Telescope Array in Chile had been tracking the object's rotation, expecting to find the tumbling motion typical of asteroids and comets. Instead, they discovered something unprecedented. 3I/Atlas appeared to be maintaining a stable orientation relative to the solar system's ecliptic plane. This wasn't the chaotic spinning of a natural object shaped by random collisions and gravitational influences. It was controlled, purposeful rotation that kept specific faces of the object oriented toward the inner solar system throughout its passage. The precision required for such attitude control would demand sophisticated guidance systems, gyroscopes, and thrusters operating continuously throughout the object's journey. Dr. Amanda Foster, who led the rotation analysis team, found herself struggling to explain the data to her superiors. Natural objects don't behave this way, she insisted during increasingly tense meetings. The rotational stability we're observing requires active control. There's no natural mechanism that could maintain such precise orientation over interstellar distances. The controlled rotation had another implication that sent chills through the astronomical community. If 3I/Atlas were indeed maintaining specific orientations, it suggested that different faces of the object might serve different purposes. Like a spacecraft with specialized instruments mounted on various surfaces, the object might be optimizing its observations by presenting the right equipment to the right targets at the right times. This interpretation gained support from the thermal imaging data, which showed that the hot spots observed by Webb corresponded to the surfaces facing toward planetary targets during closest approaches. When 3I/Atlas passed near Venus, the Venus-facing surface showed increased activity. During its approach to Earth's orbital zone, the Earth-facing regions became thermally active. The pattern was too consistent to be coincidental. The gravitational effects were equally puzzling. As 3I/Atlas passed through the gravitational fields of various planets, sensitive instruments detected tiny variations in its trajectory that couldn't be explained by gravitational physics alone. The deviations were minuscule, measurable only by the most precise tracking systems, but they were there. The object seemed to be making course corrections, subtle adjustments to its path that kept it within optimal observation ranges of multiple worlds. Dr. James Whitfield, who managed NASA's Deep Space Network tracking stations, had been monitoring these trajectory anomalies with growing concern. "We're seeing accelerations that don't match any known propulsion system," he reported in classified briefings. "The thrust is incredibly subtle, but it's consistent and appears to be directional. Something is steering this object." The propulsion, if that's what it was, left no detectable exhaust signature. Unlike conventional rockets or ion drives, Whatever was moving 3I/Atlas did so without producing the plasma trails or chemical emissions that human-built spacecraft inevitably created. The technology, if it existed, operated on principles entirely unknown to human science. International space agencies began coordinating their observations in unprecedented ways. Data sharing agreements that normally took months to negotiate were implemented in days. Telescope time, usually allocated years in advance, was redistributed to focus on this single object. The astronomical community was mobilizing resources on a scale typically reserved for solar system catastrophes. The European Space Agency's Gaia spacecraft, designed to map stellar positions with incredible precision, was retasked to monitor 3I/Atlas's trajectory. Its measurements confirmed what ground-based observations had suggested. The object was following a path that maximized its observational opportunities while minimizing the energy required to achieve that path. It was, in engineering terms, an optimal reconnaissance trajectory. Dr. Liu Wei, who analyzed the Gaia data at the European Space Operations Centre, found the precision unsettling. The trajectory optimization we're seeing would require detailed knowledge of planetary positions, masses, and orbital dynamics, she explained to her international colleagues. Either this object carries incredibly sophisticated navigation systems, or its creators had detailed maps of our solar system before sending it here. Both possibilities were disturbing. Sophisticated navigation implied technology far beyond human capabilities. Prior knowledge of our solar system suggested that someone had been studying us for a very long time, gathering the precise gravitational and orbital data necessary to plan such an intricate flyby mission. The timing of 3I/Atlas's arrival also seemed significant in ways that went beyond astronomical coincidence. The object had entered our solar system during a period of rapid advancement in human space technology. Our detection capabilities had reached the point where we could spot and track interstellar visitors, but our interception capabilities remained essentially non-existent. We could see 3I/Atlas, study it, and speculate about its nature, but we couldn't reach it, board it, or alter its mission in any way. This suggested either remarkable timing or careful planning. If 3I/Atlas were indeed artificial, its creators had chosen their moment well. They were observing a civilization that had developed just enough sophistication to recognize their presence but lacked the capability to interfere with their observations. Dr. Kenji Nakamura, a systems analyst at JAXA who had been studying the timing correlations, found the patterns troubling. The arrival window seems calibrated to our technological development, he noted in his reports. We're seeing what appears to be a reconnaissance mission, timed to coincide with our emergence as a spacefaring species. That level of planning implies long-term monitoring of our progress. Long-term monitoring raised questions about how long 3I/Atlas's creators had been watching humanity. Had they observed our first radio transmissions, our first nuclear weapons tests, our first tentative steps into space? The object's arrival during the early decades of our space age suggested that someone, somewhere, had been tracking our development and had decided that we had reached a threshold worthy of closer inspection. The psychological impact on the scientific community was beginning to show. Researchers who had spent their careers studying natural phenomena were confronting the possibility that they were analysing artificial technology from a civilization potentially millions of years more advanced than humanity. The implications were overwhelming, touching not just on science but on philosophy, religion, and the fundamental nature of human existence. Support groups began forming among astronomers and planetary scientists, informal networks of researchers who were struggling to process the implications of what they were observing. The possibility that 3I/Atlas represented first contact with extraterrestrial intelligence was simultaneously thrilling and terrifying, offering the promise of unprecedented scientific advancement while threatening to revolutionize every assumption about humanity's place in the cosmos. Dr. Sarah Chen, who had first identified the pulsing patterns in 3I/Atlas's emissions, found herself questioning not just the nature of the object, but the nature of her own career. "Everything I thought I understood about planetary science might be wrong," she confided to her therapist. "If this object is artificial, then we're not studying astronomy anymore. We're studying archaeology, xenoarchaeology." The term had been coined decades earlier by science fiction writers, but it was entering scientific vocabulary with uncomfortable frequency. If 3I/Atlas were indeed a probe from another civilization, then understanding its nature would require not just physics and chemistry, but anthropology and psychology applied to minds that might think in ways entirely alien to human cognition. As 3I/Atlas continued its approach toward the Sun, the window for definitive answers was narrowing. Each day brought new observations, new anomalies, new questions that seemed to resist conventional explanation. But it also brought humanity closer to the moment when this enigmatic visitor would complete its mission and disappear back into the vast dark between stars, carrying with it whatever secrets it had gathered about our small, increasingly connected world. The countdown had begun not to impact or destruction, but to departure. And with each passing day, the pressure mounted to answer the question that had consumed the scientific community since that first detection in July. Was 3I/Atlas a natural object that happened to behave in remarkably artificial ways, or was humanity witnessing its first confirmed encounter with technology from another star? The answer, when it came, would change everything. The final observations came during the last week of October, as 3I/Atlas reached its closest approach to the Sun. Every major observatory on Earth and in space had been enlisted in what amounted to humanity's most intensive study of a single object since the Apollo missions. The coordination was unprecedented, telescopes passing the observation baton as Earth's rotation carried each facility into darkness, maintaining continuous surveillance of our mysterious visitor. It was during this final phase that the most unsettling discoveries emerged. Not dramatic revelations that would make headlines, but subtle details that accumulated like evidence in a cosmic detective story. Details that suggested 3I/Atlas wasn't just passing through our solar system, but was actively engaged with it. Dr. Maria Santos, operating the Atacama Large Millimeter Array high in the Chilean Andes, was the first to notice the correlation. As 3I/Atlas approached its solar closest point, its emissions began to change in ways that mirrored the solar wind patterns it was encountering. Not the random buffeting you'd expect from a comet being stripped by stellar radiation, but something more sophisticated, something that looked almost like communication. The solar wind carries information encoded in its magnetic field fluctuations and particle densities. It's a river of data flowing outward from the Sun, carrying details about solar activity, magnetic field strength, and the complex dynamics of our star's interior. Most objects in space are simply battered by this wind, but 3I/Atlas seemed to be reading it, responding to specific patterns in ways that natural processes couldn't explain. The object is modulating its outgassing in direct response to solar wind variations, Dr. Santos reported during an emergency conference call with observatories worldwide. It's not just reacting to heating, it's responding to information content in the solar particle stream, as if it's designed to decode what the Sun is telling it. What? The implications sent ripples through the astronomical community. If 3I/Atlas could read solar wind patterns, it possessed capabilities that went far beyond simple reconnaissance. It was analysing our star's behaviour, perhaps gathering data about stellar stability, magnetic field dynamics, and the long-term habitability prospects of our solar system. Information that would be invaluable to any civilization considering whether this system was worth their attention. The timing of these responses was equally troubling. 3I/Atlas wasn't just passively receiving solar wind data, it was anticipating it. The object's emissions would begin changing moments before solar wind variations reached its position, as if it were predicting fluctuations in the stellar particle stream. This suggested either incredibly sophisticated sensors capable of detecting minute changes in space weather, or access to information sources that human science hadn't yet discovered. Dr. Yuki Tanaka, who had been analysing the temporal correlations at the Japanese Space Agency, found the patterns deeply unsettling. The object is demonstrating predictive capabilities that require either faster-than-light sensing or advanced modelling of solar dynamics that we don't possess, she explained to her increasingly worried colleagues. It knows what's coming before it arrives. The gravitational anomalies were becoming more pronounced as well. As 3I/Atlas swung through the inner solar system, its trajectory showed micro-adjustments that couldn't be explained by any known physical forces. The corrections were subtle but persistent, keeping the object within optimal observation ranges of multiple planets simultaneously. It was threading a gravitational needle with precision that suggested real-time navigation rather than a predetermined ballistic path. More disturbing still were the changes in 3I/Atlas's physical structure. High-resolution imaging revealed that the object's surface was reconfiguring itself as it moved through different regions of the solar system. What had appeared to be a static, rocky nucleus was actually dynamic, with surface features appearing and disappearing in response to local conditions. Near Venus, heat-resistant structures emerged on the Venus-facing surface. As it approached Earth's orbital zone, new formations appeared that seemed optimized for atmospheric analysis. The shape-shifting wasn't random. Each reconfiguration appeared purposeful, as if 3I/Atlas carried a toolkit of specialized instruments that could be deployed as needed. The technology required for such dynamic restructuring was beyond human comprehension, suggesting materials science and engineering principles that operated on entirely different assumptions about what solid matter could do. Dr. Robert Kim, who led the surface analysis team at the Korean Space Research Institute, found himself questioning the fundamental nature of what they were observing. "We're not looking at technology as we understand it," he reported. "This object appears to be built from materials that can reorganize themselves at the molecular level. It's less like a spacecraft and more like a living system made of smart matter." The concept of smart matter, materials that could alter their properties and structure in response to environmental conditions or programmed instructions, had been theoretical until now. But 3I/Atlas seemed to demonstrate such capabilities on a scale that dwarfed human technological achievements. If the object were indeed artificial, its creators had mastered technologies that humanity might not develop for centuries or millennia. The radio observations were revealing even stranger behaviors. 3I/Atlas had begun transmitting not the broad spectrum signals that might leak from technological systems, but highly focused, modulated beams directed towards specific targets in the outer solar system. The transmissions were brief, lasting only minutes, but they carried information densities that suggested incredibly sophisticated data compression techniques. Dr. Angela Rodriguez, who managed the park's radio telescope in Australia, had been tracking these transmissions with growing alarm. "The object is sending reports," she concluded during a classified briefing with government officials. "Highly compressed data packets transmitted toward the outer system, possibly to relay stations or motherships that we haven't detected yet. It's not just observing, it's communicating its findings in real time." The transmission targets were particularly troubling. 3I/Atlas was directing its signals toward regions of space that appeared empty to human observation, but the precision of its targeting suggested that something was there, waiting to receive its reports. The possibility that 3I/Atlas wasn't operating alone, that it was part of a larger network of objects or installations, transformed the entire scenario from first contact to first contact with a reconnaissance fleet. Intelligence agencies around the world began taking interest in ways that made the scientific community deeply uncomfortable. Classified briefings replaced open conferences. Data sharing agreements included security provisions that had never been necessary for astronomical observations. The study of 3I/Atlas was transitioning from pure science to matters of national security. The transformation was perhaps inevitable. If 3I/Atlas represented technology from an advanced civilization, then understanding its capabilities and intentions became a strategic imperative rather than merely an academic curiosity. But the militarization of the observations created new tensions within the scientific community, forcing researchers to balance their commitment to open inquiry with concerns about planetary security. Dr. Chen found herself at the center of these conflicts. Her discovery of the pulsing patterns having been classified at levels that prevented her from discussing her own work with most of her colleagues. "I became an astronomer to expand human knowledge," she confided to her security handler. "Now I'm generating intelligence reports about potential threats from space. It's not what I signed up for." The security concerns were amplified by 3I/Atlas's apparent ability to observe human activities. As the object passed through the inner solar system, its orientation and emissions patterns seemed to correlate with human space activities. When satellites were repositioned to observe it more closely, 3I/Atlas would adjust its own configuration in response. When deep space probes changed their trajectories, the object would shift its observation focus accordingly. The most unsettling incident occurred when the International Space Station adjusted its orbit to provide better observation angles for its Earth observation cameras to track 3I/Atlas. Within hours of the orbital adjustment, the object's thermal emissions showed patterns that suggested it was tracking the station's new position. Not just aware of the change, but actively monitoring human responses to its presence. Dr. Foster, who had been analysing the rotational data, found this mutual awareness deeply troubling. "We're not just observing it anymore," she realised. "It's observing us observing it. This has become an interaction, not a study." The interaction raised profound questions about protocols and appropriate responses. If 3I/Atlas were indeed an artificial probe sent by an advanced civilization, then humanity's reaction to its presence was itself being studied and analysed. Every telescope pointed in its direction, every orbital adjustment made to track it better, every press release about its discovery was potentially being catalogued and transmitted back to its creators. This created a paradox that paralysed decision-making at the highest levels. Studying 3I/Atlas more intensively might provide crucial information about its nature and intentions, but it would also reveal more about human capabilities and responses to potential extraterrestrial contact. Backing off from observations might preserve operational security, but it would leave humanity blind to the activities of what might be an alien reconnaissance mission. The compromise that emerged satisfied no one, but reflected the impossible nature of the situation. Official observations would continue, but with careful attention to what information those observations might reveal about human capabilities. Unofficial studies would proceed in parallel, using commercial telescopes and amateur astronomers to gather data that wouldn't necessarily reveal government capabilities or concerns. Meanwhile, 3I/Atlas continued its precisely choreographed dance through the inner solar system, apparently oblivious to the debates its presence had triggered. Or perhaps not oblivious at all. Perhaps the debates themselves were part of what it had come to observe, a probe sent not just to study human technology or planetary conditions, but to understand how a developing civilization would react to the awareness that it was no longer alone. The psychological impact on the global population was carefully managed through controlled releases of information. Initial reports described 3I/Atlas as an unusual but natural comet from interstellar space. As anomalies accumulated, the descriptions evolved to acknowledge its unique characteristics while avoiding explicit discussion of artificial origins. The goal was to prepare humanity gradually for the possibility of extraterrestrial contact without triggering panic or social disruption. But information management became increasingly difficult as the observations accumulated. Amateur astronomers, with access to sophisticated equipment, began conducting their own studies, some reaching conclusions that government scientists were reluctant to discuss publicly. Online communities formed around the analysis of 3i/Atlas data, with participants sharing observations and theories that often approached or exceeded the accuracy of official analyses. Dr. Patel, who had been analysing the thermal data from Webb, found himself fielding calls from journalists, asking questions that suggested they had access to classified information. "The story is getting ahead of our ability to control it," he warned his supervisors. "People are reaching the obvious conclusions based on publicly available data. We can't keep treating this as a security matter when the evidence is visible to anyone with a decent telescope." The pressure for transparency was mounting, but so was the awareness that transparency might have consequences that extended far beyond Earth. If 3i/Atlas were indeed reporting back to its creators, then human reactions to its discovery would become part of that report. How humanity handled first contact, whether with panic or curiosity or aggression, might determine how that contact evolved. As November began and 3i/Atlas started its journey back toward the outer solar system, the window for definitive answers was closing rapidly. The object would remain visible to Earth's most powerful telescopes for several more months, but the detailed observations possible during its close approach were ending. Soon, 3i/Atlas would become a distant point of light, then disappear entirely into the interstellar void, carrying with it whatever data it had collected about humanity and our solar system. The sense of urgency was palpable in observatories worldwide. Final observations were planned with the intensity of a space mission, every telescope hour allocated, every spectrum analysed for clues about the object's true nature. If 3i/Atlas were artificial, these might be humanity's last chances to understand the technology and intentions of our first confirmed extraterrestrial visitors. But even as the observations continued, many researchers were beginning to accept that definitive proof might remain elusive. 3i/Atlas had been designed, whether by nature or intelligence, to resist easy categorization. Its behaviors remained ambiguous, explicable through either advanced natural processes or sophisticated artificial systems. The ambiguity itself might be intentional, a way of studying human responses without triggering the defensive reactions that definitive proof of alien presence might provoke. In the quiet hours before dawn, when the most sensitive observations were conducted, astronomers found themselves contemplating not just the nature of 3i/Atlas, but the nature of contact itself. Perhaps the universe was full of civilizations that had learned to approach each other gradually through ambiguous signals and plausibly deniable encounters. Perhaps the stark, dramatic contact scenarios of science fiction were the exception rather than the rule, replaced by subtle interactions that allowed both sides to assess each other's intentions without committing to irreversible revelations. If so, then 3i/Atlas might represent something unprecedented in human experience, but common in the galaxy. A first contact designed to remain deniable, allowing both civilizations to retreat if the encounter seemed likely to lead to conflict rather than cooperation. A kind of cosmic diplomacy conducted through carefully crafted ambiguity, where the message was not in what was revealed, but in what was chosen to remain hidden. As the final observations were conducted and the last data analysed, humanity found itself balanced on the edge of the greatest question in its history. Not just whether we were alone in the universe, but whether we were ready to discover that we weren't. Whether a species that had spent its entire history believing itself to be unique was prepared to learn that it was, instead, simply the latest in a long line of intelligences that had looked up at the stars and wondered who else might be looking back. The answer to that question would shape not just our understanding of 3i/Atlas, but our understanding of ourselves and our place in a cosmos that might be far more crowded, far more watched, and far more dangerous than we had ever dared to imagine. The silence that followed those final observations was different from the quiet that had preceded 3i/Atlas's arrival. It wasn't the comfortable silence of an empty universe, but the tense quiet that follows a conversation you're not sure how to interpret. Humanity had spent months watching, measuring, analysing, and in return something had been watching back. The dance was ending, but neither partner was quite sure what the choreography had meant. In the weeks after 3i/Atlas began its journey toward the outer system, the astronomical community found itself grappling with a new kind of scientific uncertainty. Not the familiar uncertainty of incomplete data or competing theories, but the deeper uncertainty of not knowing whether they had been conducting science at all. Had they been studying a natural phenomenon that happened to behave in remarkably purposeful ways? Or had they been unknowing participants in humanity's first diplomatic exchange with another intelligence? The question haunted late-night conversations in observatories around the world. Dr. Santos, still analysing the last traces of data from her instruments, found herself staring at readouts that no longer seemed like simple measurements. Each spectrum, each thermal signature, each gravitational anomaly had taken on the weight of potential communication. What had seemed like scientific observation now felt like archaeology, the careful excavation of intentionally buried messages. And so we find ourselves here, in the quiet aftermath of questions that may never find their answers. 3i/Atlas has slipped back into the dark between stars, carrying with it whatever secrets it gathered during its brief dance through our solar system. We watched it arrive with precision that defied coincidence, observed it behave in ways that challenged our understanding of what's natural and what's not. And now we're left with the most profound uncertainty our species has ever faced. Perhaps that's exactly how first contact was meant to unfold. Not with the drama of landing craft and clear declarations, but with whispers at the edge of detection, ambiguities that let both sides retreat if needed. Maybe the universe is full of civilizations that have learned to approach each other this way, through plausible deniability and careful choreography. Or maybe we witnessed something entirely natural that happened to align so perfectly with our fears and hopes that we read meaning where none existed. The cosmos, after all, has a way of producing coincidences that feel like intentions. Whatever 3i/Atlas truly was, it's changed us. We can no longer look up at the night sky with quite the same assumptions about our place in it. Somewhere out there, in the vast dark between stars, intelligence may be looking back. And if it is, it now knows that we're here too, curious and questioning, ready or not for whatever comes next. The universe feels different now, less empty, more watched, and perhaps that's the most important discovery of all. Sleep well, fellow travellers. The questions will still be there in the morning. The questions will still be there in the morning.